There are two types of engines used in modern machines today. There are external combustion engines and there are internal combustion engines. Internal combustion engines are primarily used today in things like cars, motorcycles, boats, you name it. But before the rollout of the internal combustion engine, the external combustion engine was the most widely used. While the external combustion engine started to become popular in early to mid 19th century, it was considered an engineering marvel. It was revolutionary to technology because it made both domestic travel as well as international trade much more efficient. External combustion engines were essential to the industrialization of America and Europe in the 19th and 20th centuries, although it was eventually superseded by the much more efficient diesel engine. In this speech, I'll cover how steam works, how it reshaped trade, and why diesel replaced it. In a steam engine, you have an energy source like coal, oil, or wood, although coal was the most often used. In the front car of a train, known as the locomotive, you'll have the engineer and the fireman. The engineer is the one who drives the train, and the fireman is the one who shovels the coal into the firebox. The firebox has grates below it for the ashes to fall through the grate into the ash pan, and it also has a bunch of pipes called fire tubes. This whole contraption sits in a giant tank of water known as a boiler, and as the fire heats up the water, it turns to steam, and steam heats up and creates a pressure because as water heats up, it expands, which increases the pressure. All the pressure needs somewhere to go, so enters the steam dome. If the pressure is too high, the conductor has a switch they can pull that can release some of the steam and relieve some of that pressure. After that, the steam goes down to the cylinders through the steam pipes, and there's one cylinder on each side of the train. The steam engines on trains are also called reciprocating piston engines. Because one set of the cylinders has pistons and is connected to the driving rods on the driving wheels, or there might be just one set of driving wheels, which are the things that make the train move forward. The cylinders have a sliding valve that lets new steam in to move the pistons, and also lets old steam out, which pushes the pistons back the other way. And that reciprocating motion of moving back and forth is which moves the wheels, and it completes the whole rotation, allows steam to flow into the smoke box, take some of the leftover smoke coming from the firebox, and spit it out the top through the chimney and create those iconic smokestacks. The iconic steam locomotives everyone but aphantasiacs can picture in their mind were first designed in England in the 1820s. By the 1830s, they began to appear in America, and the railroad industry took off from there. It greatly increased the efficiency of domestic trade and transportation as commercial activity started to increase in the middle of the 19th century. During the Civil War, the North's denser rail grid moved troops and supplies faster than the South could match. With the continued growth and expansion, various innovations were utilized to increase speed. However, the boom of railroads also helped shape the economy as a whole. As economic historian Albert Fishlow explains in this chapter, internal transportation in the 19th and early 20th centuries, without the allocation of resources to transportation on a large scale and the succession of 19th century transport innovations in canals and railroads, the contours of the American economy would have been far different. End quote. Railroad stations are what led to the development of today's major cities. Railway towns are towns that started as a singular railroad station and had major cities built all around it. Cities like LA, Chicago, Vegas, and even Portland started out as railway towns. Railroads were part of an array of technological innovations, not just isolated little splotches across the Midwest. As economic historians David Mowry and Nathan Rosenberg note in their chapter 20th Century Technological Change, the vast distances that goods and travelers must cover within the United States gave an impetus to the development and adoption of technologies that could shorten travel times, reduce transportation costs, and increase reliability. In the 19th century, these were the telegraph and railroad, plus the older technology of canals. In the 20th, they were the automobile and the airplane. End quote. That being said, the railroad was not just an innovative staple for transportation, it was also a part of the backbone that made up the American economy. Though steam engines were revolutionary technology, in time they became the Dynatec 8000X of railroad transportation. Diesel engines started appearing in the 1920s and 30s, but they really started trending in the 50s. Steam engines were just too much to maintain in comparison. They ate up a lot of fuel and they required a lot more crew to operate. Diesel engines burn fuel at higher temperatures, which increases the amount of energy produced. The fuel burns directly inside the engine, moving the need to heat a larger boiler. There are 4 strokes involved in this process: intake, compression, power, and exhaust strokes. This repeats dozens of times per second. During the intake stroke, the piston goes down and takes the air in with it. During the compression stroke, the piston goes back up and pushes the air back out, which compresses it. Then during the power stroke, the diesel is injected into the compressed air, which causes it to ignite, and then the explosion forces the piston down, creating power. The piston then moves back up, which expels exhaust gas during what's known as the exhaust stroke. Diesel engines require less cleaning and upkeep. They're quicker to start up, and the eventual rollout of the combined diesel-electric engine allowed for more consistent torque and finer control of traction. As historian Maury Klein writes in his article Replacement Technology, the Diesel as a Case Study, steam locomotives were rapidly phased out not only due to diesel's superior efficiency, but also because of the broader economic shifts in the industry. As he states, the motive behind dieselization was to reduce costs, not to embrace innovation for its own sake. End quote. The shift to diesel was not merely upgrading and replacing. This also ended a vital chapter of industrial and technological advancement, during which things evolved and developed to the growing nation and economy of the era. The emergence of the steam locomotive external combustion engine helped to shape both the economy and industry, though it was eventually superseded by the diesel engine. Knowing how steam engines work help us to understand the crucial part it played in shaping trade and transportation, as well as adhering to the economic geography of the United States during the time of Manifest Destiny, which in turn paved the way for diesel to succeed in the end. Though steam engines only exist in museums and for historical rides, the legacy that it leaves behind is a ripple of waves not always seen but incredibly prevalent. Technology is always going to be there, be passed by the next new thing at some point, but the impact that innovation leaves will always be there. And then here are my speaker notes, which I'll attach with the video.